Hello, welcome back to my channel. I'm glad to have you here. Today I want us to look at some of the equations that came out this year, batch A UTME or JAMB Physics question. Now, and of course, please, this is for the benefit of those that will be writing on day 2, day 3, and day 4. Now, please, as we go through these questions, pay attention to the details of this. Remember, these questions can clone these questions. So, whichever one that is coming, make sure you don't copy exactly what is here, because JAMB may not be that lenient to give out these questions as they are. But if peradventure the questions come out like this, beautiful. Pick the correct answers and then write your exam effortlessly. Now let's go. But before we go, please, if you have not subscribed to this channel, do me this favor: hit the subscribe button, hit the like button, and then turn on your notification bell so that as soon as a new update is uploaded, you'll get notified. Now let's hit it rolling. Now we take the first one. The first one says a machine has an efficiency of 80%. If the work input is 200 joules, determine the work output of that machine. Now let's go without wasting much of our time. So we have that, of course, from the question, they said the efficiency there is 80%. Now, the work input in the machine is 200 joules. Now, what is the work output? The work output of that machine is what we are expected to get. Now, the options are there. Now, all you need to do is, among the expressions of efficiency, of course, by review of the machines, we have that efficiency is equal to work output all over the work input multiplied by 100. Now, if we go with this equation, we can now have, you substitute straight, the efficiency there is 80%, which is equal to the work output. Work output, I will put it as WO all over the work input. Work input is the WI, which is 200 multiplied by 100. Either you divide this thing by 100 or you move straight. Let us go straight. We now have 80 is equal to work output times 100 will give us 100 work output all over 200. At this point, one can only cross multiply. If you cross multiply, you have that 1 times 100 work output will give us 100 work output is equal to, now 80 times 200 will give us, of course, 2 times 8 will give us 16. You put 1, 2 plus this one, 0, 0, 0. Now, we have that we make work output the subject. Work output will now give us 16000 all over 100. Now, these two zeros will cancel out these two. And what we now have is that the work output is 160 joules. You can pick the correct answer from the options there. Now we'll move to the next question. The next question says, if the amount of heat required to raise the temperature of 1 kg of a substance is dash. I repeat, the amount of heat required to raise the temperature of 1 kilogram of a substance by 1 degree Celsius. No need wasting our time there. That the answer to that one is specific heat capacity. Specific heat capacity is the correct answer. Now, if they say the energy required to raise the temperature of a body by 1 kg, you can now pick that thermal capacity or heat capacity. Just pay attention to these questions. Should they clone them? Should they change the equation so that you can flow with them with the same frequency? Now, we put the next question. Now, the next question says, what is the primary purpose of depletion region in a PN junction diode? That depletion, why do you deplete that PN junction in a diode? Okay, now option A says to increase the diode's current carrying capacity. No. B, to reduce the diode's reverse saturation current. No. Of course, the C option is to create a potential barrier for majority charge carriers. Yes. The essence of depleting, most times you alternate the polarity. Yes. Once you alternate the polarity, what you are trying to do that time is to deplete that region. The essence of doing that is to create a potential barrier for more charge carriers to pass through. Of course, we know the charge carriers in a PN junction and the charge carriers in an NP junction. So we have so that electrons or hole can flow. Okay, the option D is not there, please. To enhance the diode switching speed. So forget about that one. So C is the correct option to that question. Now we pick the next question. The next question says, which of the following quantities is a scalar quantity? If we take a look at those questions, those options there, we have the velocity, the acceleration, displacement, and the temperature. The scalar of all of them there, the only one that is scalar quantities there is temperature. The other ones are vector quantity. You should also take note of this. They can ask you to pick up the one that is a vector quantity, or the one among the options that is not. So whichever way they choose to go, please do well to follow them. Make sure you tick the correct option. Write with confidence. Anyone that you are not too comfortable with or you are not too convinced with, please, you can leave that one. You can skip it. After answering to the end, you can come back to that one. Okay. Or maybe later I will tell you how to guess the correct option if you are not sure of those options there. Okay, now we move to the next question. The next question says, what is the implication of Heisenberg uncertainty principle for a particle's position and momentum? What is the implication? Now, I'll write something on the board. Now, we have that uncertainty principle. We have, in case they change that one, instead of telling you position and momentum, they can say, yes, of course, the S, the P is equal to or less than the Planck constant. Then they use the V, the T is equal to or greater than the Planck constant. Or they may use the P, they can use the energy delta E delta P is equal to or less than this. So these are complementary variables. Now they say, what is the implication on this? Now the implication here is that yes, this law says that yes, it is impossible to determine accurately both position and the momentum of a particle at the same time, to determine it correctly, simultaneously. This one, you cannot determine the velocity and time of a particle simultaneously to be correct. Now, in this case, that question says, what is the implication? Let us run through the options. The option says, both positions and momentum can be precisely known simultaneously. No, you cannot know two of them at the same time. As you measure one correctly, there is uncertainty in the other one. That is error. 2, the more precisely you know a particle's position, the less precisely you know its particle's, the more precisely you know a particle's position, the less precisely you can know its momentum. That is the correct thing there. Now, C says, the more precisely you know a particle's momentum, the more precisely, no, that means you can know the two at the same time. No. D says that position and momentum are completely unrelated. No? So the option is option B. Now, we move to the next one. The next one says, what is the momentum, what is the phenomenon where a particle passes through a potential energy barrier even if it doesn't have enough energy to classically overcome that barrier? Yes. Assuming we have a barrier here, let's say without a slit. Now light is coming. Since it doesn't have energy to pass through, let me use one barrier. If it's coming, since there is a barrier here, ordinarily it should turn back. But that said, what is the phenomenon that, yes, when it gets to this point, even if it doesn't have that energy, it will still pass through? What is it? So let us, before we take the correct option, let us review those options there. The options there are, from the last one, diffraction. Of course, we know what diffraction is. The spreading out of, assuming it has a slit here, and coming out here, it spreads out. Diffraction is not there. It's not the correct answer. Refraction means that when it gets through, assuming light is coming, this is angle 90, this is a normal line. Now, if light is coming, on getting to this interface here, you see it bend. No. The next one says reflection. Reflection says if there is a barrier here, on getting to this place, it will turn back. Those ones are incorrect. So the only correct option there for this light to pass through, even if it doesn't have enough energy to pass through, is what you call tunneling. So tunneling is the correct answer option. Now we move to the next one. Please, I may not be able to get all of them. Remember, these things are in types. So if this one, assuming you have written, if you did not meet all of these, please note that yes, this one is not maybe the one you wrote. There are some questions that are general questions, meaning that everyone must answer them, must meet them. But there are some that are not general. So some people may get them, some may not get them. Now we look at the next question. And this question says, a particle of mass m is attached to a massless spring with spring constant k. The particle is displaced by a distance a from its original position and then released from rest. What is the speed of the particle when it is at a distance half of its amplitude from its equilibrium position? There is no need. Of course, those equations, the only correct equation there, all of them seem to be the same. But please, mind you, option A is the correct answer option. Now we move to the next question. This question says, what is the SI unit of force? And of course, this one is very simple. You have that force is measured in Newton. In case they ask you the SI unit of force and Newton is not there, remember Newton is a derived SI unit. In case Newton is not there, Newton is not the only SI unit of force, please. In case it's not there. Now, of course, you know that force is mass times acceleration. Mass is measured in kg. Acceleration is measured in meters per second squared. In case you see this, this is the same thing as Newton. Or you can still see kg meter per second squared. This and this are the same, and they mean Newton. In case you don't meet Newton, you will always meet this one. Or they may decide to ask this question in terms of dimension. For the terms of dimension, please see the video I did last on the frequently asked questions in JAMB. See this one though. I treated some questions on dimension. Now we take this question. Some people also met some of the questions that says, what is the SI unit of pressure? Yes, some people met this question. SI unit of pressure. SI units of pressure. Some met it. Of course, we know that pressure is a force per unit area. Of course, force is measured in Newton. Area is measured in meters squared. So which can give us Newton per meter squared. So some made this. So this is a correct option. If pressure has other SI units. Of course, if pressure is, we can have atmospheric pressure, we can have gas pressure. All of them, they have there are about 4 SI units. In case you meet them, we have the one we still have pascals, which is PA. This is the first one. This is the second one. We can have bars, maybe millibar, which is in MB. Millibar is an SI unit of pressure. You can also have millimeter mercury, or cm mercury. All these are SI units of pressure. In case you met it, just note this: pascals, Newton per meter squared, millibar, millimeter mercury, or cm mercury. These are SI units of pressure. Now we take the next one. The next one says pressure is defined as, and of course I have given it here. Pressure is defined as force per unit area, which is option A there, please. We'll move to the next one. The next one says a 2 kg block is attached to a spring with spring constant 100 Newton per meter. If the block is displaced by 0.2 meters from its equilibrium position, what is the magnitude of the restoring force exerted by the spring? And of course, this question, you don't see this question as a very difficult question. Let us x-ray what are given. We have a mass. The mass there is 2 kg. Attach a spring with spring constant. Of course, let's call it spring constant or the force constant of the spring. 100 Newton per meter. If the block is displaced by 0.2 meters from it, that means that displacement there, then either you call it x or you call it the extension. The extension E, which is 0.2 meters. Then what is the magnitude of the restoring force? In this case, this one is very simple. For you to answer this, just call to mind that principle or the Hooke's law. Of course, we said that the Hooke's law states that force applied to an elastic material is directly proportional to extension, provided that the elastic limit is not exceeded. In that case, we now have F is directly proportional to E. Now, if F is directly proportional to E, if you remove this sign of proportionality, F will give us KE. Now, this F is the restoring force we're talking about. Now, F is equal to K. K is 100 multiplied by 0.2, which is the extension, 0.2 meters. And of course, F will give us, if you multiply this by 0.2, it will now give us 20. 100 times 0.2 is 20 newtons. And that is the restoring force. Now, we also move to the next question. And this question says, a car accelerates from rest to 20 meters per second in 4 seconds. What is its acceleration? Very simple. And this year, people are very, in fact, most of the work here, most people did it in the SS1. Now, we said if a car starts from rest, that means the initial speed is 0. And then it accelerates to a certain speed, which is the final speed. The final speed there is 20 meters per second. The time taken for it to do that acceleration is 4 seconds. Sorry, is 5 seconds, please. 5 seconds. Now, what is its acceleration? Either you use V is equal to U plus AT, or you use A is equal to V minus U all over T. This and these are the same. All you need to do is acceleration is equal to final velocity, which is 20 minus initial velocity. Initial velocity is 0 divided by the time, which is 5. And of course, 20 divided by 5 will give us 4 meters per second squared. The option is there. Now, we take another question. This one says, a 10 microfarad capacitor is charged to 100 volts and then discharged through a resistor of 1000 ohm. Discharged through a 1000 ohm resistor. What is the time constant of the circuit? What is the time constant of the circuit? Now, this question will bring us to the AC circuit. Now, the time constant of AC circuit is represented by the equation tau. Tau is equal to RC. RC. Now, from here, now the time constant tau will give us the from what we are given that the resistance is 1000 ohm, and then the capacitance is 10 microfarad. Remember this micro here, you must take care of it. Now, if you substitute straight, we have R is 1000 multiplied by C. C is 10 times 10 raised to power. Because of this microfarad here, minus 6. Which will give us that tau is 1000 multiplied by 0.000010. That means 1, 2, 3, 4, 5, 6. No? Okay, that means this one is what we have. 1, 2, 3, 4, 5, 6. Okay. If you multiply this by this, we have that tau is equal to, so we have 1000 multiplied by 0.0001. 1, 2, 3, 4. Okay, so if you multiply that by 1000, we will have 0.01. Sorry, we will have 0.01 seconds. So that means the time constant and that circuit is 0.01 seconds. Okay. Now we take the next question. The next question says, what is the value of acceleration due to gravity at the surface of the Earth? Remember that the Earth is not perfectly spherical. The Earth is egg-like in shape or elliptical in shape. Because it is not perfectly spherical, we have that if the Earth is represented like this, if the Earth is represented like this, now this is your equator. Now from here, the distance from here to here is different from distance from here to here. Because of that, we say that the acceleration due to gravity varies from place to place on the surface of the Earth. Now there are options given to us there, and most time they give us 9.8. Please, do not choose 9.8 only. Now the G varies from 9.81 up to 9.84. As the case will be, 9.83, please. 9.83, as the case will be. Therefore, the option there is on the surface of the Earth, it is 9.81. So we have 9.81 meters per second square as our correct answer. Do not choose 10. Most times, if it is, the value is not even up to 10, but by approximation, that's why most times we give 10. But 10 is definitely not the correct answer option. Now, we move to the next question. This question says, a 10 kg block is lifted vertically upwards by 2 meters. What is the work done? What is the work done? Now, if we have a 10 kg, mass is 10 kg. Now, distance moved, either you use h or use distance, is equal to 2 meters. Now, work done, we know that the work done is force times distance, or force times h. But F is mg. Remember, we are given mg there. So if you put mg here, that means we now have that work done is equal to, here now we have mgh. That is what we have here. So in other words, if we substitute, we have mass. Mass is 10 times g. 10 times g, which is 10 times 2, which will give us 10 times 100, 100 times 2, which will give us 200 joules. So the correct answer option is 200 joules. Now we take this question. This question says, what is the term for the opposition to the flow of electric current? What is the term for opposition to electric current? Option A, we have resistance. Option B, conductance. Option D, inductance. And C, inductance, and D, you have capacitance. Now, I will explain this. Since they said, what is the opposition to the flow of currents in an electric circuit, full stop. The opposition there is resistance. But if they say, What is the opposition to the flow of current in an AC circuit? So in an AC circuit, of course, they will have three factors there: the resistance, the inductance, and the capacitance. So these three oppose the flow of current. So no, assuming they twist they clone the equation. So in an AC circuit, inductance draw current or oppose the flow of current. Capacitance also oppose the flow of current, and resistance, they oppose the flow of current in an AC circuit. But if it is in just DC circuit or just in an electric circuit, please choose the capacity, choose the resistance, please. Now, the last but not the least, please, I could not get all the questions. These are just the ones I was able to sample from the people that took the batch A. This question says, a car travels 200 kilometers in 4 hours. What is the average speed of the car? What is the average speed of the car? Now, this one says, a car travels. Now, that means total distance traveled by the car is 200 kilometers. The time taken is 4 hours. 4 hours. Now, what is the average speed? Now, we know that the average speed is equal to total distance divided by the time, which will give us 200 kilometers all over 4 hours. Of course, this divided by this will give us 50 here, 1 here. Therefore, the average speed will give us 50 kilometers per hour. Now, I come again. In case you don't have kilometer per hour among the options, and you have meters per second, you can also convert this. Maybe at this point, kilo means 1,000. You can now say 50 times 1,000 all over hour. At this point now, hour is 1 hour, which is 1 times 60 minutes times 60 seconds, which is 3,600. Now, if you do that, you have 5 times this, 1, 2, 3, 4. 1, 2, 3, 4 all over 3600. At this point, we can divide this, and we now have 500 divided by 36. And if we have that, that means we'll be having 13.9. We'll be having 13.9 meters per second. So this is equivalent to this. In case the answer is not in kilometer per hour, it should be meter per second. This is what you will have. Now, this is where we draw this review to an end. Please, if you have not subscribed to this channel, please, I beg you, hit the subscribe button so that by tomorrow I will still update another one. Even after the JAMB, I will still be updating us on the WAEC physics. So please help me hit the like button, share this video with your friends, share it on your social media platform so that other people can have access to this video, and then it will give, once they enter the hall, it will give them that confidence. Please, you don't expect to see this question as it is here. You can also expect them to clone some of them and then give it to you. If they clone it, be able to surmount it. Now, I wish you the best of luck as you write this exam. See you in my next video. Thank you very much.